Okay, in this video we're going to learn how to, when given a function rule for a sequence, how to find values of that sequence using the explicit rule and using the recursive rule. And we're actually going to talk about what each of those two terms actually means. Okay. So here's our first example. It says a go-kart racing track charges $5 for a go-kart license and $2 for each lap. If you list the charges for 1 lap, 2 laps, 3 laps, and so on, the list forms this sequence of numbers. And so I've got the sequence right here. So, you know, if you're just going to go 1 lap, it's that much, 2 laps, 3 laps, and 4 laps. So the first number in the sequence represents your cost for 1 lap, so on and so forth. So if we want to fill in the rest of this table, this n is how we refer to a number's position in a sequence. So for example, the number in the first position is a 7, or in other words, for 1 lap, you're going to be paying a total of $7. 2 is 9, so we see that for 3 laps, we're going to be paying 11. For 4 laps, we're going to be paying 13. And so we can just keep this pattern going. Basically, with every additional lap, we can see that our common difference, or our rate of change, is 2. So for 5 laps, we're obviously paying for $15, and 6 laps would be $17. Okay, so that's kind of a basic introduction to sequences. The things that we need to know is that that n is referring to the position number. Okay, what position is that term in the sequence? Is in the first position. Is n equals 5? That would mean it's over here in the 5th position. And then f of n, that's just our function notation to describe our output or our dependent variable. What are the actual numbers in the sequence? Okay. So our first type of rule in a sequence is an explicit rule. An explicit rule for a sequence, that defines the nth term as a function of n for any whole number n greater than 0. Explicit rules can be used to find any specific term in a sequence without finding any of the previous terms, and that's important. Now, what this first part of this definition means is an explicit rule for a sequence defines the nth term for any n. Okay? That basically means if I tell you the position number, this explicit rule will spit out the actual number in that position. So in the previous problem, that explicit rule, that problem we talked to with the 7, 9, 11, and 13, the explicit rule for that is this f of n equals 2n plus 5. So you can see that if I were to take a 1, my position number, and substitute it in and work it out, the answer would be this 7. For the number in my second position, if I were to put a 2 in for n and work it out, 2 times 2 plus 5 would give me the 9. So I can use this function, if I know the position number, to find any term in the sequence. So for example, to find the 15th term, I'm finding f of 15, so I'm finding what is the value of this sequence in the 15th position. And I can work that out and see that my answer is 2 times 15 is 30, plus 5 is 35. So if I were going 15 laps on that go-kart problem, I'm paying $35. F of 16 is 2 times 16 plus 5, which is going to be $37. And F of 17 is obviously 2 times 17 plus 5, which is going to be $39. So we can use these explicit rules so I don't have to count out this sequence and keep going with my pattern for 100 numbers. I can just substitute the term number into my function and find the answers that I need. Okay? So if I kept this pattern going and kept going and kept going and kept going, I now know that the 15th, 16th, and 17th numbers in this sequence would be these values right here. That's what we just calculated, okay? That's how we use an explicit rule to find sequence values. Now, let's talk about recursive rules, and I'm actually going to skip this slide. So, a recursive rule defines the nth term by relating it to the previous term. So In the last problem, we know that f of 1 is 7. And let me just copy down my sequence here. We got 7, 9, 11, 13. So our recursive rule in this case would be that the function is equal to f of n minus 1 plus 2. Now, we need to talk about what this f of n minus 1 means. We know that the n is our term number, okay? So n is our term number. So if n's representing any term in the sequence, then n minus 1 is just referring to whatever the previous term number was. So for example, by saying my function at n minus 1 plus 2, what I'm really saying is my previous term plus 2. So that's just another way of describing it. So basically I take whatever the previous number was and add 2 to it to give me my next number. And you can see that over here. If I take my previous term and add 2 to it, it gives me my next term. And then I move here. If I take my previous term and add 2 to it, it gives me my next term. So a recursive rule is good for finding the next term when you already know a term. Okay? And so we are actually going to, I'm not going to go into those right now. We're going to stop right there for now.